Developers often need a way to generate temporary credentials to access their cloud accounts. In this video, we'll show you how to generate temporary Google Cloud Platform IAM credentials as needed using HashiCorp Vault. Hi, I'm Emily, an engineer working on Google Cloud Platform and open source integrations between Cloud and HashiCorp Vault.
And I'm Andy, a product manager at HashiCorp on the Vault team. Vault is a secrets management tool that allows you to store, manage, and control access to tokens, passwords, certificates, and other types of secrets.
In our last video, we used HashiCorp Vault to secure an API key for our 80s-style arcade game, Hyperspace, and gave our GC instances an easy way to access secrets on GCP using Vault. Now let's talk about other ways we can use Vault on GCP. Let's say we want to add a daily leaderboard to our video game. We'll have it update at midnight each day, so it needs to access our video game data stored in Spanner at least once a day. Should we just give it its own service account key and access to our Spanner database?
Well, what happens if someone steals the service account key? If you don't have it locked down, as well as the main app, and it's all an automated process, how would you detect if it gets stolen? That won't be good. What if you just gave it temporary access to your project, like a temporary IAM credential?
Yeah, that would work.
You should check out the GCP secrets backend for Vault then. A secret backend in HashiCorp Vault is a pluggable interface that can store, generate, or alter secrets. The GCP secrets backend dynamically creates OAuth access tokens based on IAM service accounts and policies. This means you can generate credentials to access GCP as needed without needing to worry about how long those credentials last.
That actually sounds like exactly what I need. If I could see how this would be useful in other cases too. Things like batch jobs or virtual training accounts don't need access to your GCP project for very long, but can be hard to clean up after. Developers could use Vault's GCP secrets backend to assign the minimum permissions to their initial service accounts and obtain additional permissions only as needed.
Want to try it out?
Sure. So as you can see, we already have our Vault server up and running on GCP from last time. We'll show you how a server admin sets up the GCP secrets backend and how a user obtains a new secret or a GCP OAuth access token.
The admin needs to add configuration details such as credentials. The Vault server uses this config to make requests to GCP to set up IAM permissions.
Next, the admin needs to add Vault-specific role sets. These determine what permissions the service accounts created by Vault will have. The bindings argument is a configuration file where we specify GCP IAM roles to assign to each resource.
Can we take a closer look at this bindings config file?
Sure. Each block in the configuration file specifies a resource and a set of IAM roles. As you can see in this block, we've given the resource name for our Spanner database that contains our scoring data and the role of database reader. This tells Vault to give generated service accounts permissions to read the scoring data from the given database.
So the secrets backend is set up then, right?
Yep. Let's switch to a different terminal now and show how our leaderboard app gets an access token.
To obtain our OAuth access token, we read from the creds endpoint, specifying the role set we want to generate the token under. Vault generates the token using a service account it creates and then returns this token.
When the TTL or time to live is up, Vault revokes the lease and the access token in turn. We can then use this OAuth token to call the Spanner API. Now that we've finished a request to Spanner, we don't need access. Let's revoke this token manually. That was really easy to do. Andy, if other developers have questions on setting this backend up, where can they get more information?
So check out the vaultproject.io page and look up documentation on the GCP secrets backend.
Thanks, Andy. You can also check out other information for running Vault on GCP, including using the GCP authentication backends, or using GCP with other HashiCorp tools like Terraform. See the links in the description below. Bye.
Bye.
Thanks everyone for watching. We hope you found this series on using HashiCorp Vault with GCP helpful. Check out the links in the description below and don't forget to subscribe to the channel.